Hello, I am Ilia Christadoni, and together with my colleague Dimitra Tsakanika, we are managing the EU projects sector of DAEM, that is the IT company of the city of Athens. In Assured, we're responsible for the smart cities use case, and with this demo, we want to demonstrate the functionality that has been developed so far, and we're going to do it in collaboration with our colleague Stefanos Vasiliadis from Ubitech, that is also going to participate further on in the demo. Let's see what is the scope of our demonstrator. So with this current demo, we would like to focus on the functionality of the DAEM, and we are going to explain further on in details about it. But starting with a general scope, our use case mainly is the main key concern for our use case is privacy, since we are referring to urban safety systems that involves the transmission and the exchange of data that are quite critical because it refers to the citizens' privacy, so data from sensors or cameras. So it is really, really critical to prevent the misuse of such information and possible attacks against citizens' privacy. So far, there has been several approaches followed in the research that have to do with privacy authentication services. However, the big throwback is the fact that that they are centralized systems and they create a quite complex ecosystem. So recently, it has been proposed the Direct Anonymous Attestation, a decentralized approach, DAEM, that it is actually a protocol designed in another sector, in the automotive, in the transport sector. It has also been researched, and we are now going to test it in Assured for the smart cities. And this is designed to offer privacy within remote attestation. So in Assured, the DAA is further enhanced, and this is what we're going to showcase today, because it allows a device to self-actually issue short-term anonymous credentials. Another very important issue is the fact that it provides a feature of revocation. It is possible to revoke credentials from an end user or from a device in case of misbehavior or malfunction, as we're going to explain further on, without breaching the privacy of other devices. In this current demo, we are going to showcase how the DAA is enhanced through Assured, and the integration of this critical component with other components such as the blockchain. It is ongoing. So how is DAA important for the use of the public safety? First of all, trusted devices, on the enrollment of trusted devices or sensors, they can actually create certificates through the TPM wallet component. And the creation of pseudonyms are actually a feature that protects privacy. And the DAA is really efficient for the revocation of devices that they are malfunctioning or they are compromised. So in the Assured framework, the security context broker can issue a revocation request that what it actually triggers is to delete the pseudonyms and the certificates from the devices, or disable the generation of new pseudonyms, and then the device needs to be re-registered. This happens because its DAA key is connected with a revocation index in the security context broker. Also, policy regulations through the Assured framework that are governing the pseudonyms are a functionality that it is used by the TPM-based wallet. So the current flow, the flow of the demo that Stefanos is going to explain further on, follows the architecture as you can see. So initially, this starts when a device requests an enrollment through the privacy CA. And then the issuer actually sets up the DAA and a trusted component, so the Assured TPM wallet produces the certificates, for the addition of the edge device. In our case, it's going to be a gas sensor. These certificates are registered in the security context broker, and in case that the device is compromised or malfunctions, the revocation feature is triggered. And further on, Stefanos is going to explain both how the soft and the hard revocation are taking place. The soft revocation refers to a single pseudonym, the revocation, the deletion of a single pseudonym, and it is in case that a device malfunctions. So then when it can easily be restored to the normal function. But in case there is a behavior of a device, then we go to the hard revocation, where all pseudonyms are revoked and the device needs to be registered again. And now I'm going to pass the floor to Stefanos Vassiliadis for the rest of the demo.
Hello everyone, I'm Stefanos Vassiliadis from Ubitech, and in this video I'm gonna showcase the flow of the enhanced DAA and revocation scheme. For this purpose we have created two third-party trusted entities, the issuer and the revocation authority, which are respectively located at the top and the bottom right side of my screen. Upon ignition, the device commits to a chain of verification events with the issuer, which leads to its DAA signature verification in order to prove that the device is indeed trusted. If the verification is successful, the device creates 2 to the power of 63 pseudonyms for signing the data and registers their public keys and their corresponding CP hashes to the revocation authority in order to be revocable and ready for use. As you can see here, the verification was indeed successful, and then the device proceeded to registering the public keys to the revocation authority. For the functionalities we want to perform, we have created a service through which we call the device to sign the data we want. Every time we call our service to sign the desired data, a different pseudonym is picked to perform the signature, and by doing that we achieve anonymized and privacy prevented signature. Right now there is no sensor attached to the device, so this functionality is performed with some dummy data. As you can see, the device chooses a pseudonym and returns the public key and the signature. Every time we call, a different pseudonym is going to be chosen. Additionally, we are able to both soft revoke a pseudonym and strip it of its signing capabilities, and hard revoke a pseudonym, which takes the signing ability of every pseudonym, and then the device needs to be rebooted. So let's perform a soft revocation. As you can see now, the pseudonym was successfully revoked. So if I continue to ask the device to sign new data, when it comes across to the revoked pseudonym, it pass it and take the next available pseudonym to sign. As you can see, the pseudonym was revoked and can be used for signing. So let's perform a hard revocation now, and as you can see, the device was terminated and it needs to be rebooted in order to perform any signing activities. Thanks a lot for your time.
Thank you very much for following this demo.